Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about spectroscopy, especially UV visible spectroscopy. So, the content of today's talk is introductions, Beer-Lambert's law, instruments of UV visible spectrophotometer and their applications. Now, friend, the spectrophotometer technique is to measure the light intensity as a function of wavelength. We are measuring light intensity as a function of wavelength. It does this by diffracting the light beam into a spectrum of wavelengths, direct it to an object, receiving the light reflected or returned from the object, detecting the intensity with a charge coupled device, and displaying the results as a graph on the detectors and then the display device. You can see here the light source, collimator lens, wavelength selector slit, monochromator prism or grading, sample solution in cuvette, detector photocell, digital display or meters. You can see I0 initial intensity of light and after time t light. So single beams, light source, wavelength selector, monochromator, P0 sample, P light detector, computer, meter or chart to display results. In double beam, light source, scanning, monochromator, motor, rotating mirror, beam chopper, sample cuvette, reference cuvette, P and P0, mirror, semi-transparent mirror, detector and display. So compound absorbed light radiations of a specific wavelength. The amount of light radiation absorbed by a sample is measured. The light absorption is directly related to the concentration of the compound in the sample. As the concentration increase, light absorption increase linearly. As the concentration increase, the light transmission decrease exponentially. So these are the Lambert's Beer law. Light absorbance A log I0 by I epsilon CL. Light transmittance I by I0 10 to the minus epsilon CL. I0 light intensity entering a sample, light intensity existing in sample, the concentration of an light in sample, the length of the light part in glass sample cuvette, a constant for particular solution and wavelength. Now instrumentation, light source, provide a sufficient of light which is suitable for making a measurement. The light source typically yield a high output polychromatic light over a wide range of the spectrum, X-ray, UV, visible, near IR, microwave. Monochromator accepts polychromatic input light from a lamp and output monochromatic light. Monochromators consist of these parts: entrance slit, collimating lens or mirror, dispersion element, focusing lens or mirror, exit slit. Now dispersion device, a special plate with hundreds of parallel groove lines. The groove line act to separate white light into the visible light spectrum, white light source and diffraction grating. The more lines, the smaller the wavelength resolutions. Instruments, focusing devices, combination of lenses, slits and mirror, relay and focus light through the instruments. Now you see the cuvette, CUVETTES cuvettes, designed to hold sample for spectroscopic experiment, made of plastic, glass or optical grade quartz, should be as clear as possible without impurities that might affect a spectroscopic reading. Detectors convert radiant energy photons into an electrical signal. The photocell and phototube are the simplest photodetectors, producing current proportional to the intensity of the light striking them. You can see the cathode and anode. So display device, the data from a detector are displayed by a readout device such as an analogous meter, a light being reflected on the scale, or a digital display or LCD. The output can also be transmitted to a computer or printer. You can see here. So application, concentration measurement, and prepare samples, make series of standard solution of unknown concentrations, set spectrophotometer to lambda of the maximum light absorbance, measure the absorptions of the unknown, and from the standard plot read the related concentrations. Detector of impurities, UV absorption spectroscopy is one of the best methods for determining of impurities in organic molecules. Additional peak can be observed due to impurities in the sample, and it can be compared with that of standard raw materials, standard PCM with impurities. So structure elucidation of organic compound from the location of peaks and combination of peaks. UV spectroscopy elucidate structure of organic molecules. The presence of or absence of unsaturation, the presence of heteroatoms. So chemical kinetics. Kinetics of reaction can also be studied using UV visible spectroscopy. The UV radiation is passed through the reaction cell and absorbance changes can be observed. So detections of functional groups, absence of band at a particular wavelength regarded as an evidence for absence of particular group. Molecular weight determination. Molecular weights of compounds can be measured spectrophotometrically by preparing the suitable derivatives of these compounds. For example, if we want to determine the molecular weight of amine, then it is converted into amine picorates. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.